How can you use visible light to determine the concentration of a solution? This is our solution concentration lab. It really is all about color. Color is around you every moment of every day. Whether you know it or not, it affects your moods, the decisions you make, even the choices you make. Take these two apples. I love apples, and I know this red apple to be sweet and delicious. I also know the green apple to be tart and crispy. Sometimes I want the red apple, sometimes I want the green apple. Imagine how disappointed I would be if I bit into the red apple and it tasted like the green one. The same is true when I look at colors in solution. Here are two of my favorite sport drinks. They have exactly the same ingredients. The only difference between the two of them is color. And yet when I make my choice about which color to take, it really depends on what I'm about to do. For example, if I'm about to get started in a really hard workout or a hard sport, I'm more likely to pick the red. Why? Because to me, red is stronger, red is more energetic, red is stimulating. And then at the end of the workout, when I'm tired and depleted and need a little bit of sustenance, I'm more likely to pick the blue because it is the color that I use to cool down with. Now, the amount of color in solution also matters. If I am getting ready to work out, am I likely to pick this kind of red or this kind of red? The science that studies the difference in the amount of color in a solution is called colorimetry, and that's exactly what we're going to be doing today. In fact, in today's lab, we are going to be using a model ionic solution of copper 2 sulfate. It is this beautiful aquamarine color. And our lab today is going to come in 3 parts. First part is we're going to actually see how a colorimeter sees the color of copper 2 sulfate. The second part is we're going to be generating a standard curve or a calibration curve using different concentrations of copper 2 sulfate. And the last part is we're actually going to take a solution of unknown concentration and we're going to be using that calibration curve in order to quantify how much color is in that solution. It's a full plate today. Buckle up, let's get started. To set up this experiment, we start with a 1 molar solution of copper 2 sulfate, and we use the solution to make a number of serial dilutions. The dilutions that we're going to be using for today's lab are 0.04 molar, 0.08 molar, 0.12 molar, 0.16 molar, and finally 0.2 molar. We are also going to be using a wireless colorimeter for this experiment. The last thing you want to do is to take your samples of dilutions and actually transfer them into the cuvettes that we're going to be using for this experiment. So let's look at how data is collected. The first part of this experiment says, as asking the question, how does the colorimeter see the color of the copper ion? And in order to do that, we're using one of SPARKvue's quick start experiments specifically made for the colorimeter. And this is an absorbance and transmission configuration file that we can use to determine exactly what wavelength we would like to use to study the color of the copper ion. I have just put into the colorimeter my sample of copper 2 sulfate, and I'm going to start this experiment right now. The moment you see the colors pop up, it tells you very clearly what wavelength is perfect for studying the absorbance of copper 2 sulfate. In this case, it looks like our copper 2 sulfate absorbs beautifully in the red range, 650 nanometers. I can actually use some simple tools to scale this up so that you can see it even more clearly. Now, in the second part, we're going to create a calibration curve now that we know exactly what wavelength we need in order to study the copper ion in solution. And in order to do that, we are going to move into a new experiment. And we're going to use a Beer's law file. Beer's law is a calibration technique. We are going to be using Beer's law to generate that calibration curve. We have to make a few changes to this because, first of all, we know, for example, that the optimal absorbance for the copper ion in our situation is in the red range. So I'm going to make that change there. And the y-axis on our graph will also be changed. We also have to enter the concentrations of copper ion that we're using for this experiment. So I'm going to actually put those in right now manually. 0.04, 0.08, 0.12, 0.16, and finally 0.2. I think we're set. Let's start with our first sample. We're going to press that start button. And immediately you're going to see an absorbance reading in the red range. Once that number stabilizes, all you have to do is press the check button and you're ready for your next sample. Now, as we're going through this, I want you to notice that everything that is coming up on our table on the left is being plotted automatically by the software. That brings to an end all of the samples we had, but if you look at our graph, it looks a little squashed. So I'm going to do a very, very simple manipulation to scale that graph properly so we can actually see it. The software has now expanded our data so we can look to see exactly where all our points lie. In the next section, we're going to do a little bit of analysis using some of the tools on SPARKvue, and then I will throw in that unknown, and we're going to see how we can use SPARKvue to figure out the concentration of our unknown. Analysis of our calibration curve is made very simple using our software. Here are the values that we've already come up with. All I have to do is use one of our tools here that actually draws the best curve line. As you can see, our data falls beautifully along a very straight line. That is good data when you're generating a calibration curve. Even better than that is that the software actually tells you your slope and your y-intercept. Why is that important? That's important because you're going to need those numbers when you figure out exactly what the concentration of the unknown is. And that is the third part of this experiment, how to use the calibration curve to determine the concentration of copper ion in our unknown. And we're going to be doing that right now. This is our unknown solution. We hope that it falls somewhere along our calibration curve. The colorimeter tells us that we have an unknown concentration that is reading at about 2.48 absorbance, which is well within our calibration curve. Now, how do you use the calibration curve to determine your concentration? Okay. Think about the equation y equals mx plus b. Let's see what you already have. You've got the m. You've got the b. You even have the y because that is exactly what this number is. Now you just have to solve for x.